In this video, we are going to look at experimental observation of muons. Now, muons are unstable elementary particles that have a charge equal to the charge of that of electron, and mass is 207 times that of electron. Muons are produced by the collision of cosmic radiations with atoms high in the atmosphere. Now, slow-moving or muons or almost stationary muons in the laboratory have a lifetime that is measured to be 2.2 microseconds. If these muons are moving with a speed of 0.98 c, what will be the lifetime measured by the lab technician? So we can see here that the lifetime of these muons as measured in the rest frame is 2.2 microseconds. So this muon here is stationary and it is decaying, it is living for 2.2 microseconds. So we can see that proper lifetime is 2.2 microseconds. Or if you want, you can write that as 2.2 into 10 to the power minus 6 seconds. But if these muons are moving with a speed of 9.98, then obviously if we are observing it, like I'm sitting in my lab, I'm the lab technician and I'm watching this muon and I'm trying to measure its mean lifetime, then it will be different because I'm not in the rest frame of this rest frame of these two events, the creation of the muon and the decay of the muon. So the lifetime that I would measure as a lab technician would be delta T that I need to find. We are given that U is equals to speed of this muon is 0.98 c. Now using this, first we can find the Lorentz factor. So Lorentz factor is 1 upon square root of 1 minus 0.98 c over c square, which basically is nothing but 1 minus 0.98 square, and that comes out to be 5.025. And with this I should be able to find the observed time delta t, that is gamma time delta t 0. So I have 5.025 times 2.2 microsecond, and that comes out to be 0.5 microsecond. So this is the time that is measured by the lab technician. Lab technicians will see the muon living for this much time on an average, and in this time muon will travel some distance. Muon is traveling with a speed of 0.98 c, and as per the lab technician, the muon lives that long. So the distance traveled by the muon before decaying is distance d is equals to speed times time. So speed is 0.98 c, which is 3 times 10 to the power 8 times 11.05 10 to the power minus 6. I have converted that into this time into seconds now, so it will be 11.05 10 to the power minus 6 seconds. And this is my c here, that's 0.98, and I plug these values in calculator and I come across a distance of 3316.64 meters. So as per the lab technician's observation, the muon on an average will travel a distance of 3,316 meters, which is almost 3.3 kilometers. Yeah. If there were no time dilation, then the distance traveled would be straightforward. Our muon has a lifetime of 2.2 microseconds and is traveling with a speed of 3 times 10 to the power 0.98 c. Let me write this as well. So muon is living for a time of 2.2 times 10 to the power minus 6, and it is traveling with a speed of 0.98 c, and this will come out as 660 meters. So if there were no time dilation, the muon would travel this much distance on an average before decaying. Now experimentally it has been observed that muons are not traveling 660 meters. Muons are created in the upper atmosphere, and if there were no time dilation, none of the muons would be able to reach Earth because it's too far. They will decay within 660 meters on an average. But experimentally it was observed that many of the muons are able to reach Earth, and that would happen. They're able to reach Earth by after traveling 3, 4, 5 kilometers, 6 kilometers. Only possible explanation is that time dilation is actually happening. Basically, this is the first experimental proof of time dilation. There are few other cases as well. So what we see is that anything which is moving faster, will age slowly. So we can think of a situation where there are two twins there. One twin goes on a interstellar traveling at a very high speed. One other twin remains on Earth, and so this person, the twin who is on the Earth, for that twin, time will run faster, and the twin which is on the spacecraft, time will run slower. So what will happen is that the person who is traveling on the spacecraft will not age as much as the person who is on the Earth.